Hello all, I am Jacob, and I will be doing an introductory course on the SAS programming language today. SAS is a statistical software, and it's also an acronym. Stands for the Statistical Analysis Software. And I'm going to just get right into it. I open my start menu and I go to SAS here, and I'm just going to open up the application. This workshop assumes that you have access to the SAS programming language and that you also have no experience using SAS or programming at all, really. So now that my SAS program is awake, I will briefly talk about each of these windows that are displayed. Right now, the first window that's selected from this tab here at the bottom, the editor window. And this is where I would type my programs. I type my commands. This is the communication platform between myself and the program, such that I tell SAS what I want it to do in this window, and SAS does what I say. Which brings me to the next window right above the editor window, which is the log window. And that is where SAS communicates to me after I submit my program from the editor window if there are any notes, any problems, or errors. SAS will place them in this log window. And this is the window that I always like to check if there are any problems whatsoever. Or I usually just like to check it after every time I run a program. And then there's this Explorer panel on the left-hand side. It's essentially like a Windows File Explorer, where I can navigate through folders that are on my desktop. And there's also results down here. If I had generated any results so far, they'd appear, but obviously there are none. And I'm going to use this libraries section in the Explorer panel on the left. Double click on it to open it up. And what's great about this demonstration is I'm going to be using a system sample dataset. So anybody who has access to the SAS program will also have access to these help datasets. So this can always be reproduced. I'm in my libraries. Now I want to go into the SAS help library to see sample data sets that SAS provides me that I can use to practice my skills or do a demonstration. And for this quick demonstration, I will use this class data set. And we see by looking at this logo that it is a SAS dataset. And a common statistical procedure would be just to make sure that this dataset actually has contents in it. It's not just an empty dataset. I like to left double click on my class dataset, which will make it appear in this view table. So now I can see, oh, this data set has 5 variables. It has a string variable, a string meaning a string of characters together. That is the name variable. It's got a character variable in the gender or the sex of the individual in the class, and it displays the age, looks like the height in inches, and the weight in pounds. And so I'm going to close that, and I want to, make some changes to this data set. For at least the goal in this, just looking at this data set, is I want the height that's in total inches, I want it to be in two separate variables. One that says feet and then inches, as that seems a little bit more straightforward to me. And I also want to create some regression and output my results. And I'll get there when I get there. But I'm going to begin by clicking into my editor window. And I will begin my first step of the SAS programs, my first SAS program. All SAS programs consist of two steps. There is the data step, in which I import my data. I can add new columns, variables, and I can manipulate my data set and organize it in any way that I desire. I can apply formats and do a variety of things to the data set. That is the first step. And then the second step of SAS programs are the Proc step, short for procedures, that will generate my results, graphs, averages, or regression equations. But I begin with my data step, and I start by typing data and a space. After I type data, you realize that SAS color codes that word to be blue. And blue is usually very good. Blue, good. Red is bad. And green are comments. You notice that I had typed the data in all capitals. So SAS is not case sensitive, where if I type data in all lowercase letters, then it still recognizes the same command that I'm attempting to do. And I'm going to call this data set, I'll call it class_2. Quick little tidbit about naming criteria in programming and in SAS, where it has to begin with a letter or an underscore, which I did, starts with a C. It cannot contain spaces in the name of data sets, and it can be alphanumeric, so I can embed numbers along with text in my naming criteria. And now I add a semicolon, where in SAS, that is the end of a statement. The beginning of the statement typically, almost always, begins with a keyword. In this case, my keyword's data. And it ends in a semicolon. I am telling SAS to create a new SAS data set, assign it this name class_2. And then when it encounters the semicolon, I'm telling SAS, well, get ready for the next command that I'm about to type. And I want to use this class data set over here in my SAS help library as my reference data set. I'll left click on it once to highlight it, and I right click on it to get its properties. as in programming and in SAS, I need to tell SAS where to look for data. Otherwise, it will have no idea what data set I am referring to. I see right here in the location, I'm just going to highlight that and copy it. And I'm going to paste it right here. Of course, that only tells me the data set itself. This line did not begin with a keyword. It's not blue. So I go back to the beginning of the line, and I initiate the set command, which is the keyword to initiate the command to open up a data set. Specifically, open up a SAS data set of this kind of format. I can't use the set command to open up Excel kind of data sets or text file data sets. If I wanted to do that, I could use commands, or alternatively, I could use the menu file, import data, and navigate through this wizard of, look at that, Excel workbook type of data, and many, many other kinds of varieties that I can import into SAS. But right now, I just want to open up this class dataset. I mark the end with a semicolon. I go to a new line and I type run semicolon, as that marks the end of my data step. This is technically a program that I just typed up. It's very short, it's very brief, but it is still a program such that I create a data set called class_2, and I'm taking the contents of this class help data set and putting it into my own SAS data set. And then the run semicolon marks the end of the data step. I would not be able to do any of this without the run semicolon. So that needs to be included at the bottom of every data step and at the end of every procedure step. And now I'd say I'd like to start to run this program. I have a variety of options to do this. So I'll begin by just going up to the menu, making sure my editor window is selected. I go up to the menu, the Run menu, and I click the button Submit. And that will run the entire, all of the text typed into the editor window, which is okay right now because I only have a couple lines typed in there. But as my program gets more and more complicated, I will probably want to run my commands in a different fashion. So I just created a data set called class_2. I check my log after running my command, as I usually do. It prints a copy of the statements that I'd submitted, and it gives me some notes. 19 rows were read in with 5 columns. Just as I had seen when I opened the data set just by double-clicking on it in the SAS help section. Now I'm going to submit my first procedure step, as what I've done is I stored the data inside of this object class_2, but I actually want to see these numbers. I want to see the data set itself. And that I initiate, just like I did with the data step above, I'm now going to my proc step, the second feature of my program. And that begins with the word proc. And then I specify the name of the procedure that I want to run, in this case, the print procedure. And lastly, I must tell SAS what is the data set that I'm going to view. I type data equals and the name of the data set from above, class _2. Recognizing that with SAS in these syntax, that it's really just one word after another, and a space is the operator that separates in a SAS statement one part of the statement from the next part of the statement. You realize if I keep Proc Print all in one word, then the font turns red and SAS reminds me, hey, this is not good. If you try to run this, this will produce an error. I make sure to mark a semicolon at the end of my line. And here's another quick tidbit about SAS programming, is I don't need to enter a new line for every single new statement. I did because I like that form of organization. And I like to program how I like to program. And everybody's different. Everybody has their own likes and dislikes and preferences. Perhaps maybe I would like to have this log window a little bit tinier so that I can have a larger code entering. And also maybe I'd want my Explorer window to be a little bit larger over there. I don't know, just preference. But I can configure anything I want. And in this Proc Print procedure, SAS is smart enough to realize, well, the beginning of the command starts with a keyword, and it always ends with a semicolon. And once SAS encounters a semicolon, it knows that it is ready to address the next statement, whether that's on the same line or whether that's on a different line or 3 lines down. It really doesn't matter. And this time, rather than running the entire program again, this is how I prefer to run my commands, where I just highlight the snippet of code that I want to run. I navigate up to this toolbar with this little running man icon. I hover over it and it says submit, the same button where if I went to the run menu and press submit. I just like to do this because that's one less mouse click. I initiate that proc print command and I see my data set automatically pops up. And it appears just like it did when I double-clicked on the class dataset. You also see that the results window automatically populated as well with my first procedure that I've created. Nothing out of the ordinary here. But to jump back to a little bit of the purpose of what I wanted to do, was I wanted to convert this height in inches variable into 2 separate variables. One column that will tell me the feet of the person, and one that will tell me the inches, so that it's in feet and inches kind of method. I activate my editor and my log windows, and this is how I like to program. Everybody, of course, is different, and anybody can program however they prefer. But I like to start off with a simple kind of procedure and then add more complications to it one at a time, then running my program after I make each addition, just to make sure that if there is an error that occurs at any point along the way, then I will know where it happened. So I enter a new line, and I'm going to initiate the syntax for creating a new variable, adding a new column to my data set. Since I'm making a change to the data set itself, it goes into the data step underneath this set command that opens the data set. And you know, this would be a great time for me to add a comment. And to do that, I add an asterisk at the beginning of a line, or a star. And just like SAS programming I've talked about so far, I add the asterisks, and you see that the run semicolon turns green. Green font is not interpreted by the SAS program. The green font is only there for my benefit. I use it for reminding myself what the program is going to do, what's its purpose. And even more so, if I were to send my program to other researchers, that they don't have to necessarily know SAS extremely well to understand, you know, what's really going on. They can just navigate through my comments and realize, oh, well, I understand English, and I can tell what this program does, not by analyzing the statements, but just by reading the comments that the coder provided me. So I'm going to add a comment to convert height to feet and inches. And just like every single SAS statement or command, a comment is technically a SAS statement, and it must be ended with a semicolon. So I make sure to end everything with a semicolon. That is the most classic error that occurs in SAS programs, just forgetting to put a semicolon at the end of the command. Now I said I wanted to convert height to feet and inches, and such I will create a new variable. I'll call it feet. And this is one of the only commands, one of them, where it does not begin with a keyword. Creating a new variable in SAS does not begin with a word where the font is blue. It begins with the name of the column that is going to be added to this new data set. So I'll call it feet. And this is a pretty general syntax for programming in general. You have on the left-hand side what you're going to be naming this new column. Then you have an equal sign in the middle. And then on the right-hand side will be what will be set equal to this feet variable. And there's a lot that I can do as far as creating variables. I can create a constant variable. So if I just set feet equal to 2, then it would be 2 for every single row in the data set. I could set the variable to be a constant, but also containing text. So text here, and if I use that method, then I have to enclose them in quotation marks. And I can also create a variable based off of other variables and an expression and using functions. And that is, of course, the method that I will be using this time. I say feet, and I know that, well, there's 12 inches in a foot. I'll take the height variable and I divide it by 12. I make sure to add a semicolon at the end of my command. Realize adding that semicolon before this run semicolon is just, it's not color coded. Running this program itself would give me an error message because what SAS is thinking is actually like this, and that is not an acceptable statement. So I add my semicolon. I'll run all of my commands and I see, well, feet was added to the data set. However, it wasn't particularly added to the data set in the way that I wanted it to. It contains decimals, and I'd rather the feet variable be just a solid number, rounded down to the nearest integer. So there's still some more work that needs to be done to my program, which is why I like to approach it in this method where I just make one little tiny change and then I check out the results, see if it's what I want, and if it's not, then I go back to my program and make some more changes until I get the output that I want. And for this to work the way I want, I'm going to initiate the floor function. I type floor, I put parentheses around my expression height divided by 12, as that will make it so the feet variable is rounded down always to the nearest integer. I run that program and I see, aha, that's exactly what I wanted. I've got the feet. But now I need the inches column added. So this first person, who is 69 total inches, they would be 5 feet and 9 inches is what I want this new column here. Inches for this one to say 9. I go back to my program. I initiate a new line in which I will call a new creation of a variable. I'll call it inches. And, looking at this data set, how would I get the inches? Well, what I really need is the remainder of the total height divided by 12. So if this person was 69 inches, I divide that value by 12 and the remainder would be 9 inches. That's what I want as my result. But perhaps I don't know the function or how I need to accomplish that. So I'm going to open up a web browser and I'm going to turn my attention to Google, as there are many, many things that can be learned from Google. If you ever have questions like, how do I get a remainder? Or if you get an error message and you're not sure how to resolve the error message immediately, then you can copy and paste the error message into Google. But in this case, I'll say SAS remainder function. Sure, that seems about right. I look at this output from the internet and it says the documentation of the mod function. I'll go right to it. Documentation.sas.com for the mod function. Now, with my programming experience, I've heard of this before. The mod is short for modulus, which essentially means the remainder. And with this, I see, whoa, I've got this online SAS documentation that, quickly found the function that I was looking for and provides me the syntax and how to use it. Awesome. So now what I want to do is check out this page, and this applies for like all programming languages. Always have this documentation to help you out in times of need. I see the syntax here, mod, start parentheses, and you know, I'm actually going to highlight that. I'm going to copy it, and right above where I initiate the inches command, I'll add a comment. So I can use that as a reference. That is the syntax that it's supposed to use. That is what I will mimic, which is a key part of programming. Being able to look at the syntax and look at other people's uses of these commands and take that information and apply it to your own situation. And many times they have sample codes down here in these documentations that they provide. So I see here like X1, they have modulus 10, 3. What I would imagine they're going to divide 10 by 3. What's the remainder of that? Well, the remainder is 1. So I scroll down some more. They stored that into X1. So I scroll down to X1, and it is, in fact, 1. Aha! So the command is what I'm looking for. This is the function. And now I just need to apply it. You know, I'm actually going to copy that little snippet of the command too. And I'm going to paste that in part of my comment as well, so that I can use that as a reference. Now I've got everything I need. Looking at the line above, I see I'm going to type mod. I'll open my parentheses. And in their examples, they're providing an actual constant value. Now my value is the height variable. It's changing for every single row. So what do? I just type in the height variable as my dividend expression, and my divisor in this case is 12. 12 inches in a foot. I close out my parentheses. I add my semicolon at the end of the line, and I'm going to highlight my commands and submit them to be run. And the output automatically comes up, and I see, oh yeah, the inches is displayed just as I had desired. Awesome. And I'm going to continue on this creating of variables just for a little bit longer. And I'm going to create a binary group. I'll add this in my comment. So before my run command, I'll say create binary group. I'll say people that are shorter than 5'6" group A. Then people who are, otherwise, they'll go into group B. And that is my task. And so I will initiate the if structure, which is everywhere in programming. If this condition is true, then perform this action. If this condition is not true, then perform this action, and so forth. So I want to see if people are greater than 5'6", then they go into category B. If they're shorter than 5'6", category A. So I'm even just going to get right into it. If I'll say feet is less than 5. Then the group, which is a new variable that I'm creating, will be equal to A. And I make sure to include my A in quotation marks. Then I add a semicolon to end that command. And I say else if feet is greater than or equal to 5. Then group will be equal to B. Add a semicolon, and let's run this and see what I get. I run the command, and it says, whoa, hold on here. I see some of the contents of this group variable have A assigned to them for the people who are less than 5 feet, but the rest of the people, I wanted them to be in category B. But B here showed up as its own column. I mean, what's going on here? The first thing I do is I look at my log. Let's scroll up, see what we get here. The log prints a copy of the program that I just submitted. It tells me here as a note, variable B is uninitialized. Wait, well, I didn't want it to be a variable. I wanted it to be a part, an answer to a column. But, oh, here we go. In the line above, I had included quotation marks around A, and that worked successfully. Now I need to add the quotation marks around B, or else SAS will assume that B is supposed to be its own new column. And that's not what I want. And, you know, there was also a second error that I made here. Not that was marked in the SAS log, but in my comment above, I said I wanted people who are shorter than 5.5 feet would be in category A, otherwise category B. In my code, I had only accounted for people who are shorter than 5 feet. I need to include that other extra 6 inches. Easy enough. I will add a relational operator where I'll include this ampersand to say if you are less than 5 feet and your inches is shorter than 6, then you go into group A. Also, I'll add that to the command below. If you're greater than 5 feet and your inches are greater than 6, then you go into group B. Okay, I think that I have got this. I will click on my running man icon to submit my commands. And I see, well, I fixed the problem where there's no column B here that's empty. But something here's going on. Why isn't this person who's 4 foot 8.5, why aren't they in category A? Why didn't that work? And a lot of these people, this person who is 4 foot and 11.8 inches, why aren't they in category A? So I go and I check my log to see if there's anything that will help me there. No, not really. It tells me that, you know, everything kind of worked correctly. So it's got to be something in the way that I typed the code. The code is, the syntax is fine, such that SAS understands it, but the code itself is not grouping the data the way that I want it to. And I see here, right in front of me, what I have in this condition here is people who are less than 5 feet and people whose inches are also less than 6. Both of these conditions need to be satisfied in order to be into group A. That's where my problem lies. What about people who are less than 5 feet, like that person, 4 foot and 11 inches? Sure, they pass this condition of less than 5 feet, but they don't pass this condition of inches being less than 6. So that's what I need to work on. I need to add another condition to this if operator. And just to clean it up, I'll add some parentheses. My cutoff is 5'6". So I can keep this condition as it is. If people are less than, I'll add an equal to. No, just an equal to. If people are equal to 5 feet and they're less than 6 inches, then they go into group A. That is true. But I also need to add an OR operator, as I need to include people who are less than 5 feet, like that person who is 4 foot and 11 inches, or their feet are less than 5 feet. And that's really all I need to include, I would say. So there we go. And similarly, I'm going to mimic this in the command below. But first, I'll run this output just to see if it was actually successful so far. So this person who's 4 foot 8.5, they're in category A, just like I wanted. And this person, 5 foot, 4 foot 11, looks like the category A worked exactly how I wanted it to. And category B worked almost the way I wanted to, except for this little tidbit here. This person, Philippe, who is 6 foot tall and 0 inches. Jumping back to my code, I see you only fit into category B if you have feet that is 5 feet or higher, and you have inches that is 6 and higher. That is where the problem lies. What about people who are 6 foot 0 inches? They technically don't fit into that category, so that's why they're missing. I'm essentially going to copy the format from above, just switching the direction of these operators. So if you're equal to 5 foot and your inches are greater than or equal to, I'll say, because this one just says less than, I want to include people who are 5'6". From my comment above, people that are shorter than 5'6", which is this, will be in category A. Everybody else in category B. That includes people who are 5'6". And I add this OR operator, and I say OR feet are greater than 5. Just like I had done in the command above, essentially just mimicking that format. And I think that is all good. I'll run my program again just to see, did it work the way I wanted it to? I think it did. This person who's 6 foot 0 is in category B. 5'7" B, 5'6.5" is B. And I've correctly created this binary group variable of text that fits people into these specific groups. Now I'm starting to get a ways into my program, and I want to make sure at least that I save this editor. That is the only thing that is making it so my work is reproducible, this code. So I go click on the editor, I do File, and save as, and I'm just gonna find a place on my computer where I can save it. I'll put, let's see, I'll create a documents folder here, and I'll place that in here. I'll just call it code. Ha ha ha. And now I want to move on a little bit. I've done a lot of work with the data step, and now I want to turn my attentions more to the procedure step of this statistical analysis software, as I think the majority of the work and the time-consuming aspect with programming in SAS and most other programming languages is the cleaning up of the data set, organizing it, and restructuring it in the way that you are able to analyze. So I've done that. I have restructured. And now I want to do some analysis. I'll add a comment here, and I'll say, you know, looking at my data set, I want to see, well, how many people of this data set are males? How many people are females? I also want to see, well, a very common practice would be to calculate the averages of the weight, but also calculate these averages based off of another group. So what is the average weight for males? What is the average weight for females? So I'll include that in my comment here. I'll say frequency counts for males and females. I'll say average weight of all people and for males and females. Cool. And, you know, I do know what these procedures are just because I've used SAS before. But similarly with looking up information if I'm not sure. Say SAS, I'll say frequency procedure, where, you know, what is the syntax for this frequency procedure? Like how do I make that work? I know what I want, but I don't know how to type it. I don't know how to code it. So I can see here, you know, Proc Freq. Here's the syntax. That's what I type. All right, cool. Okay. And there are all the statements or sub-arguments to this procedure, where the by, the exact, the output, tables, test, weight, blah, blah, blah. And it tells me here a little description of each of those subcommands. The by statement separates the analysis by a group. Hey, that sounds just like what I wanted when I wanted to see how many males were in the group, how many females. So I'll go back to my SAS program. I remember with the syntax, I type, and I'll even reference it again, up here. Proc Freq, these same color-coded, blue, that is what I have to type in. I have to mimic that part. Every procedure begins, whoops, with, make sure to add a semicolon to my comment. Every procedure begins with the word proc. Then I type the name of the procedure, Freq in this case. I specify the data set that I'm referencing, data_2. And I add a semicolon. That's the end of that part. I'll jump back to my syntax, as the by option is probably what I want to use here. And this is how it works. I type by, and then I replace variables with whatever variables I want to perform my analysis, split that by. So go back to SAS, I say by, and looking at my data set, the variable name is called sex. So I place that in by the sex variable. And to end the procedure, I add a run semicolon. Ha ha! Highlighting, this time I don't want to run the entire code of printing the data set, doing the data step. I just want to check out the frequencies, and that's all. So I highlight my little section of frequencies. I submit my commands, and automatically the output should be generated. I'm going to check the SAS log to make sure that there weren't any errors, and alas, there were. Usually the output gets automatically generated. The data set is not sorted in ascending sequence. The current by group. Okay, so that's kind of what tells me that, well, I need to sort my data set in ascending sequence, I guess. I go to Google again, in which I can search for SAS, and how do I sort a data set if I'm not familiar with it? Sort ascending. And I'll go right to the same link that I've been going to, documentations.sas.whatever. That seems to be working well for me. It provides me with a syntax, and it provides me with examples sometimes too. I like that. And right here is what I want. This code with the by statement. It would only make sense that I use the by in my Proc Sort, as well as using the by in my frequencies procedure. I'm going to actually copy this command, and since I need to sort the data set before I run the frequencies procedure, I need to make sure to add it above using the frequencies procedure. And now I'm going to initiate a different kind of comment. It's called a block comment. It begins with a / and then an asterisk. And this comment can go until the end of time, technically. But it goes for as long as until it encounters an asterisk followed by a / So that is the beginning of the comment. This is the end of the comment. And any semicolons in between, well, doesn't matter because it's part of the comment. I'm going to use that as a reference. I type proc sort data equals class _2, because that's the data set I'm using. They include this out equals option, where that will create an entirely new data set based off of this sorted results. I don't really want to do that to create another data set. That might be a little bit confusing. I'll just sort my pre-existing data set and I'll roll with that. I add a semicolon. I add the by option by and the sex variable. I add my semicolon and a run semicolon. And by default, let's see if they mention this in the documentation. But by default, ascending is the order that will be sorted in. Of course, it looks like I could add this other option, well, right here. Ascending is default. I don't have to say that I want to sort it in ascending order. It'll assume that's what I want. But if I want to sort it in descending order, I mean, I don't, but if I wanted to, then I would include descending, type that in before I include the variable name, kind of like this. You know it is a good acceptable argument because after I finish typing descending and press space, it turns blue. But that's not what the SAS log told me. It said it wanted it in ascending sequence. So I'll highlight this sort procedure and I'll click run. I see that in my log, there were no error messages. Cool. I've done everything that SAS told me to do to fix this error that I was having with the frequencies procedure. So now I'll roll back after I made these changes and see, will this give me a frequencies procedure or will I get an error message? And it gives me the frequencies procedure. But it's certainly quite messy. I'm not sure how much this really helps me. And you know, looking at my output from this, I don't think I wanted to do frequencies based by the gender. Rather, I wanted to see how many males and how many females are in the data set. So I'll jump back to my proc frequency syntax and I see, well, the by statement isn't necessarily what I wanted. What in these descriptions do I want? Aha! The tables option, which says specifies tables and requests analyses. That sounds a lot more what I want, where it will create only the table for the sex variable. I delete my occurrence of the by subcommand in the proc frequencies, and I replace it with tables. The syntax past that is just the same. It references the variable name. I'll highlight those commands and I will run them. I submit them to see where I expect a table just like this. 10 males in the data set, 9 females, and basic statistics based off of frequency counts and percentages. So I've got that. I'm happy. Highlight my code window and save it as I've come quite a distance. And even if I wanted to, many times using this log window and having a record of that could be helpful as well. So if you want, you can highlight the log window, file, save as, and it will, right here, you save it as a log file. So SAS log, you know. It's kind of cool. And what I'll do right now is I'll proceed with a means procedure. So I'll add my comment, means procedure. And I add a semicolon. And shortly after this means procedure, I'll do a close-up on all of the code that I've typed so far. I might as well do that right now. I didn't want to, well, I did want to have this zoomed in the entire time, but it causes my mouse to move kind of slow, and I don't particularly like that. But this is the data step that I've typed thus far. And I'll keep that on the screen for just a little bit before I address the means procedure. I mean, check out the color coded of the syntax here. Every single, well, most every single statement begins with a keyword, and the keyword is colored with blue font, except for the creation of new columns, new variables. You see that text inside of quotation marks are colored with purple type of font. If I were to make some changes that are not acceptable for SAS, then I would get, either normal colored font or sometimes red colored font, which would indicate that, well, this is a problem. But I'll keep that as that is. So that is my data step and one of my print procedures. And then below I have my sorting procedure, which probably didn't really get used in the end, at least for this frequencies procedure, because I changed the frequencies procedure. But that was still nice to go through and look up the documentation of the sort procedure and how that works and how I can sort ascending or descending or any of those really. But I'd say I'd be ready to go right into the means procedure here. And just to make it so my screen is not moving at a snail's pace, I'll get rid of this zoom. Oh my gosh. Okay. And now I'm going to add a couple lines. Well, actually, it's down here. Haha. Means procedure. I'll actually look it up. Similarly, I don't really know, perhaps, how this works. So I'll say SAS, and I'll say the means procedure, which will, if I could spell, then we'd be in business here. Which will calculate, basic summary statistics, the average, the standard deviation, and honestly, any other statistics really that I can think of. But it tells me Proc Means in the option. The by option, I'm going to jump back to that by separating it by the gender of the person. And I can export this as its own data set. I can specify certain variables as opposed to other variables. So I'll include at the top, my ultimate goal is to do a means procedure of males versus females, weight. That's the end goal. And I'll start with my simplistic approach of beginning with Proc Means and making it pretty straightforward, telling SAS what the data set I need to produce the means procedure off of. And I'll just start with that. Proc Means and a run semicolon. When I highlight these commands and run them, it will generate the means, average, standard deviation, minimum, and maximum of all the numeric variables here. So the average age out of everybody, 13 essentially. The average height out of everybody is 62 inches, a little bit over 5 feet. And weight for, 100 pounds. Now back to my comment above, I said I wanted to do it by males and females, that as the separator. So I type by the sex variable to calculate that. I'll quickly open that up just to see how that rolls. I mean, I've got my own exact table as I had above here, but now it's split by males and females. So I see the average height for females is shorter than it is for males, as is the weight less than males. And now I'd say, well, I don't really want it to see the age variable, and definitely not the feet or the inches variable. That doesn't really mean much. So I look at my syntax again, and I see, well, I just used this by option. Now I want to use this var option. Var option standing for identify the variables that I want to include in my output. So I said, well, I don't want to include the feet. I don't want to include the inches in the output. I just want to look at the weight. So I add another option, var weight of the participants. And I'll highlight that and I'll run it to see that now only the weight is given. As I had mentioned, females, the average weight is less than the average weight for the males, as is the standard deviation, the minimum, and the maximum. And I really like the output that was created by this basic means procedure. And thus, I want to create it as its own type of SAS dataset, where if I go back to the documentation for the Proc Means procedure, there is this output, out equals SAS dataset option. That is what I want in this case. I'll check out the syntax and look at some of the examples for how I can actually use this feature for the means procedure. Right now, I'm just scrolling down to the bottom to see if there's any examples, and there are not. So I will have to do this on my own. The syntax tells me to type output, out equals SAS dataset. So I can do that. I add a new line before the run state in between the proc means and run. Output, output, out equals, and I can assign this name to anything that I want it to be. I'll say it is weight underscore AVG, remembering that creating of these dataset names must not contain spaces. And I think I'll start with that. I believe by default it'll look like that proc means output that was generated right here. But just to be sure, I can do a proc print with the data equal to just what I created, weight underscore AVG, just so I can see actually what this data set looks like. What SAS data set did I just create and what form does it take? So it shows me a little bit different order in the output. This is more transposed, but yeah, it gives me all the features, the minimum, the maximum, the average, and the standard deviation. It appears when I go back to the syntax, perhaps I just want the average and the standard deviation by the males and the females. So it looks like I can have output statistics specifications and ID group specifications. So I can list these descriptive stats that are present in this table, and I can set them equal to, well, their own names necessarily. So I'll give this a go. It looks like I want mean, and I said I wanted the standard deviation. So I will type in my out option, I'll add mean equals, which means I'll take the average and I'll store it as the average. And std equals standard underscore dev. Now I want to see, I expect this output, at least with the proc print, to show exactly this. Aha, just the average and just the standard deviation of each group. And it looks better than this graph that I had before. So I'm happy with that. Now that I have this nice looking weight underscore AVG dataset in the form of a SAS dataset, it doesn't really help me that much for sending this to other people. It only aids if the other people I'm sending this to actually have and use the SAS programming language. That'd be the only way that they could open this data set unless they had a converting software. So rather, it's a good practice to, I have a data set in here that I like, that I'd want to maybe send to somebody. So I'm going to export it using a procedure and export it to be an Excel file so I can easily send that along to a coworker or another researcher or myself maybe for an assignment. This procedure is Proc Export. I specify the data set, which is, in this case, weight underscore AVG. But now I'm going to export this data set. The export procedure. I look at the options for this command, and I have it open. I looked at the syntax before, but out file equals, and this is what I'm going to set the location where I'm going to save this Excel file. So earlier above, when I imported the SAS help class dataset, I had to tell SAS, where to find the dataset. And SAS help is actually a prefix name where SAS knows when it sees that name, it has a specific folder location to look at, and then the name of the data set. Similarly, I'm going to go to my documents folder that I created, and I see, oh, there's where my code is, that's where my log is. I think I'm going to also paste my data set there that I want with the averages. So I click up here in the address bar, and to get the full path of this folder, I copy the path, and I'm going to paste it inside of quotation marks. So that gives SAS the location of where I want to save it. Now I have to assign it a name, which I'll call averages class. Actually, I can use spaces in this one because it's enclosed in quotation marks. And I also need to make sure to add the file extension. So I wanted to export as an Excel file. So I'll include the .xls Excel file extension. Or maybe let's try with a CSV file. I like that. And I add a semicolon, and that should be all. Do a run semicolon statement and see, there's something bugging me here. I think with this out file, since out file is not blue colored and it's at the beginning of a line, I'm thinking maybe this semicolon, this out file needs to look more like this. I can put it on the new line, which is fine. And I will keep it that way. But there needed to be no semicolon there, which is a great catch. But I'll run that command. I'll look at the log to see as it's processing stuff. And it looks like, yeah, the note tells me that a CSV file was exported. To go to my folder, I see there is my CSV file. I had export it as a CSV because on this system, I actually do not have an Excel application, so I couldn't open it using that application. So I figured I'll just open it with a Notepad application just to confirm that there are, in fact, numbers in there and to see if the export worked successfully. And it did, a comma separating all the values, the gender, the type, the frequency, the average, and the standard deviation. How about that? Awesome, awesome. That is some good stuff. And I'm starting to come to the conclusion of this workshop. I have a couple more things that I want to talk about. One in particular would be, I had teased the idea of creating a regression equation, and that's what I'm going to do. I'm going to proceed with that thought. And I'm going to use this class_2 data set. And I'll add a comment here to say, now create regression. And I'll say a correlation as well. And I want to predict the height in inches based off of the weight of the person. Not really the most legitimate regression, but just to use this as an example for programming and for coding and whatnot. So I'll begin, I know I want to create a regression. I know I want to do a correlation, but I don't know the syntax for either of those. So I head back to my trusty online source. I'll say SAS, and I'll just say correlation. Like, how do I create that? And I'll pick one of these links probably at some point. I know that this link here with the UCLA is very exceptional. And this correlation looks very straightforward as far as the syntax here. You say proc core, you specify the variables that you want to correlate, and you type run. Are there more details here? Oh yeah, look at that. So I can create a scatter plot as well. I'm actually going to do both of those. So I'll take my correlation command and I'll use this as a reference again, as I've done before, just taking some of the code that somebody's provided me online. I'll paste it in my same SAS code file and just use that as a reference and apply those situations to what I have in my SAS program. Because I'm not using this kind of data, I'm not using their data or variable names, but I can just fill those in where needs to be changed. And this is very helpful here. I got the syntax right in front. I'll just essentially mimic everything. Proc core data is equal to the class_2 marked with a semicolon. It seems here I list the variables that I want to correlate, which I said I'm trying to predict the height based off of the weight. So I'll include height and weight as my variables, and simply with a run command. And that should be all that's needed for my correlation procedure. And while I'm at it, I might as well just type out the code for this proc gplot to create the scatter plot. This is typically the process one would take before performing a regression equation. You check out the correlation coefficients to see the linear relationship between the two variables. And then it's nice to see a visual representation of the data that I'm also trying to predict. and then to boom, actually match an equation to that. So I type, proc gplot, data is equal to what I've been doing. I simply type plot and the variables that I want to plot with a star in between them or an asterisk. And this time the star in between them did not make it a comment. That's part of the syntax. The proc statement ends with a run, and it appears I have to add this quit semicolon option too, just because I do what the syntax says. And in time, I'm going to highlight all of these commands and I will run them to see, well, let's see what I get. I don't expect to get any errors. That'd be nice. So here's my graph. Looks like a moderately strong positive linear relationship. As the height of the individual increases, so does the weight typically. And looking at the correlation output up here, yeah, it is pretty moderately strong, almost to the point where it's quite strong linear relationship by looking at these values of the intersection tells me the linear relationship, which is always a value between 0 and 1. If it's a positive relationship, the closer the correlation is to 1, the stronger the linear relationship. The closer the value is to 0, the more spread out the values are, and the less likely you'd be able to draw a line of best fit to summarize these points. Of course, the correlation can also be between 0 and -1 if the slope of my line or the graphs are in a negative direction. So that was nice, very good. Nice using of the syntax and the documentation online. Thank you. And to complete this, I will finish it up by doing a SAS regression just to get me the formula. And I'll look here with this support.sas, nice little documentation provided by SAS, I would think. So straightforward as it gets, I can add this Proc Reg model. Wow, it looks like they're using the same data set as me. They just might be. No, it's very similar, but it's not exactly the same model as we, but they are predicting weight from height. I'm doing it a little bit in the opposite direction, but that's funny. I will again, as I've been doing, copy and paste that command as form of a syntax guide for me. And then I'll just copy it in my own typing. Proc reg with a semicolon, the model as what my dependent variable to the left of the equation, what I'm predicting, which I said I wanted to predict height from weight from up here. And I set that equal to weight. And then it looks like I just had a run semicolon, and that would complete my regression procedure. As I had mentioned before too, that creating the organization for your output, or I mean your data set, manipulating it and restructuring it in the way so that it's prepared for analysis is typically the time-consuming part of this procedure. But actually creating the regression equation, that takes almost no time at all. As you can see, I just typed 3 lines of code and was able to accomplish that like no problem. And I'll see my output, run my code to see, oh, I see. It says, oh, the variables are not found. I hadn't specified a data equals here class underscore 2. Otherwise, SAS doesn't know, like, okay, you want to predict height and weight, but from what? What are you predicting it from? I'm just telling SAS, hey, predict height and weight. And it's like, well, okay, I don't know what you mean. I don't even know where to look. So I make that edit. I run the command again. And usually if the output doesn't automatically get generated and print to my screen, then I know, okay, there's something wrong. And so here are all of the features of a regression equation. I'm not really going to talk about the output themselves. Quickly, when I look at this UCLA help documentation website that I looked at for the correlation, they typically go through each of the facets of the output and they explain what they mean and how I can interpret them. So that's usually a good location if you want to understand the statistics side of actually understanding what this means. But in short, right here in the parameter estimates section is where I would create my regression equation. And just going off of that, I'll even type it out in a notepad application quickly using this information. So if I'm predicting the height, I'd say, height, predicted height is equal to 42 point plus times the weight. So with every 1 pound increase in somebody's weight, it is expected that their height would also increase by almost 1/5 of an inch. That's essentially what that regression equation is telling me. And this is great. I like this output. And if I ever wanted to, if I was doing this for a report, I wanted to create a report and send this to another user, really, I can take the output that's generated from this results viewer and I can send it along to a PDF file, to a Word file, to a website kind of format. I am going to focus on sending that along to a PDF file. And this takes the form of, we use what's called an ODS for Output Destination System. And I type at the beginning of where I want to start exporting my results, I type ODS PDF, meaning I want to create a PDF. I want to export all the results, the correlation results, the ggplot, and the regression results. I want to export all that to a PDF file. And I'll say, I should look up the syntax for this because I'm not 100% sure. So the SAS ODS PDF. This is always a good idea. Just if you don't know, then you can always check out. I didn't want to download a PDF. I just wanted this more so. Just to remind myself, I never really tried to memorize things, at least when I'm programming, because I know that there is a documentation online somewhere. And, I don't have to memorize anything because I can always refer to this online documentation. So I'm looking for some examples I think would be nice. But here we go. It looks kind of nice. File equals and then a path location. That appears to be what I want. Although I'm still looking for some more examples. Oh my gosh, I'll be scrolling forever if I go at that pace. Ah! I found something I thought. Here we go. ODS PDF file equals, and then I specify the location of the file. So I've already got the ODS PDF. And I'll add a comment, say export correlation, graph, and regression results to a PDF file for sending to others. ODS PDF file equals, and in quotation marks, usually when I'm dealing with file paths, I'm always including quotation marks. So quotation mark, I want to send my output to this folder where I've been saving everything so far. So I go to the folder in which I want to send my report. I click in the address bar and I copy the path. Use an absolute path in this case. I paste it back in. I add a backslash. So that tells SAS the location. Now I need to tell SAS the name of the file, which I'll say it's reg for regression. Got to add the extension .pdf. I close out the quotation marks. I make sure to add a semicolon. And this ODS PDF, I'm not sure that it specified it here in the output part. Ah, here it is. Where I need to include this ODS PDF close at the end. So SAS, what it's thinking is, okay, I see this line of code. SAS is thinking this. And it goes, I'm going to create a PDF file, and the output that gets generated from every command after this will be sent to that PDF file that I created. But SAS also needs to know, well, when are we done with the PDF file? I need to know when to stop adding content to the PDF and when to close it and save it and actually have it be in a location where it can be opened. So at the bottom, I include ODS, PDF, close. It works in the form of like brackets or giant parentheses where everything in between ODS PDF file and ODS PDF close will be inside of my PDF. Similarly with a lot of SAS procedures, everything in between the Proc Means and the run semicolon statement will be performed as part of the means procedure. And just with the data step as well. Everything between the creation of the data set with the data statement and the run semicolon, that will be run. If anything is outside of it, then that will probably cause problems. But I highlight all of these ODS commands and everything in between. I submit my statement, and I'm looking at the log while it's running, and I think that by default, the PDF will automatically open up. I might not have the opportunity. I might not even have PDF on this as well, so I probably can't open that up. How about that? Yeah, I have no way of opening up a PDF file. Ah, boy. So quickly, just to really prove that this works, I'll switch this PDF to an RTF. Well, it did work as far as PDF. Like here's the PDF file. I just don't have an application to open it. So I'll switch this to an RTF, which means rich transcript file. Essentially a Word file or a Notepad application. I saw that I had a Notepad application. So I'm going to make that change the PDF to an RTF in the file and in the close as well. And I'll run that again. And this time I should be able to open the output in an actual kind of file rather than just saying, oh, there's the PDF file, but I can't really do anything with it. Yeah, say that. What happened? Oh, geez. I forgot to, I changed it ODS RDF, but I need to actually change this as well. The file extension to say RTF. Silly mistake. I just exported another PDF file. So I make that change to include the correct file extension. Now when I go to this location right here, it says a rich text document, just as I had kind of mentioned before. Once this is done running, which it just completed, I will check it out. Some content is blocked. Well, I want to see everything. And here we are. This is the correlation that I had created. It opened in a nice word pad so I can see the output. This would be what looks like that was the regression equation. And I didn't see the graph there. Perhaps that was some other content that got blocked along with it. It didn't look like any of those graphs came along. Probably because of this type of file format. But the graphs would be right here. They're just, for some reason, not being displayed. So it's there. Yeah, I can even select the graph item, but I just can't see it because of this kind of file format. Oh well. But I've come a long way again, so I'm going to save my code file. And a couple very final tidbits to talk about here. I want to apply a format to a couple variables. I want to create a permanent SAS dataset. What I did right here with this class_2 variable, or dataset, I mean, if I go to my Explorer tab, and right now by default I'm in the SAS help, so I go up to this toolbar and click on the up one level folder level to get back to all my libraries. By default, SAS will save the data sets that I create into this work library, which is fine, which is acceptable. See, there's my class_2, there's my weight_average. And it's fine to save them there if you use the method of exporting to a CSV file or a different kind of file to an actual location that you can send. But once I close out of SAS, once I click out of this X in the top right corner, this work library and everything that's inside of it will be erased and it will be cleared. And I won't be able to access that again. It'd be cool if I could save this SAS data set to this documents folder so I could open it up and do stuff with it, moving forward, rather than having my SAS datasets get cleared every time I close out of SAS. And to do that, I would create a personal library. Syntax for that, I start libname for the library name. I assign an alias, a nickname to this library name. I'm going to use my initials, separate it with a space, and then I tell SAS, okay, whenever you see the initials JG inside of datasets, then refer to this following path. So I opened up some quotation marks. I go to the folder where I've been saving all of my stuff. I get my address bar and I copy it and I paste it inside of my library name statement and end it with a semicolon. So now if SAS knows, I can associate two level names, which is actually what this SAS help part is. It's a two-level name, begins with the location, a period, and then the name of the data set. SAS help, there's not an actual folder necessarily around here that says SAS help. It's the program sees that SAS help and realizes, oh, this means I need to look in this specific spot to find the data set. And that's the same kind of way with this as well, where I can add a JG and a period to this class _2 data set, and that will send it to this documents folder. It'll save it there. So I'll run all of these commands. I'll check my log to make sure, yeah, everything, the library was created successfully, nothing wrong. When I actually go over to my Explorer window again and click on this little up-level arrow button, I see that now a new library has been added, the one that I just created. And if I double-click inside there, there's my class 2, created just because I made this change. And when I open up the folder, there's the class 2 data set in its SAS type of format. Now, to make this more reproducible, I would have to, add a JG and a period to pretty much every occurrence hereafter, I'd say, when I'm referring to data sets. It'd be a wise idea. So, but I'll avoid that for now. And the last thing I wanted to do was I wanted to apply some value labels where I created this group of, you fit into group A if you are 5 feet and 6 inches or shorter. And you fit into group B if you're 5 feet 6 inches and taller. So I want them to say, rather than the group saying, oh, group A or group B, I want them to say, shorter than 5'6", greater or equal to 5'6". And this is another procedure. It's called proc value. And as I've been doing with all my procedures, I come up, I open my web browser, and I search SAS proc value. Like how can I use this procedure to create value labels for my information? And it looks like I might have been mistaken. It's Proc Format is the actual name of the procedure. And then I do value and add the options. So I had a little bit mistaken that. I was hoping again for some examples. There's some, looks nice. That can help me out hugely. So I go Proc Format, with a semicolon. This one, I have to include the proc format before this data set. If I'm going to apply formats to these variables, then the formats have to be created before I'm actually referring to the data set. So proc format, I type value, and going back to the documentation, I type the variable name followed by the labels that I'm going to assign. So the variable name, and I apply the name to this format. So I'll call it group underscore FMT. Another thing with these naming criteria is no spaces. I use underscores for spaces, and must begin with a letter or an underscore. It can contain numbers, but I didn't want to in this case. And then I put a space, and I'll put a new line actually just for organization. And it says, well, every time an A is encountered, I want that to be displayed as shorter than 5'6" and I'll use that kind of. There we go. And similarly, I'll add the B group is equal to, I'll say 5'6" and taller. Those are the people who fit into that category. I make sure to end that with a semicolon. I'll add a run semicolon as well to complete the procedure. And lastly, I create a new line at the bottom of my data step. And this is where I'm going to apply my format. I type format command. The keyword turns blue once I add the space. I specify the name of the variable that I want to apply the format to, group, and a space. I specify the format that I want to apply to this variable, group underscore FMT, and I believe I add a period to that and end it with a semicolon. And now I'm going to make sure to add this JG to the Proc Print so that the correct data set will actually be printed. And I will highlight all of my commands. Not all of them necessarily, but the ones that I want to run, starting at the proc format and ending at this proc print with the data step in between. And the error message is, oh dear. It says the format group was not found or could not be loaded. Aha. It must be something with the way that I am trying to apply a string format to a string as well. In all of these examples, they show, aha. So I look down here, it looks like I need some changes. Maybe if I'm using quotation marks, that the variable name has to have a $sign before it. That makes sense. So I'll put a $sign here as the syntax provided. And it also looked like it wanted single quotes on the left-hand side here. So I'll change those to be single quotes on the left and big quotes on the right. Just making some changes, looking through the documentation. Thank you for that online help. And I highlight my commands again, I run them, and I see that's much better. The output has, rather than saying group B, it says 6 inches and taller. Rather than saying group A, it applies that label to it. I've completed it. I'll save my code. I'll check out. This is all of the work that I've created. And thank you for listening in. Have a great and excellent day.